Alright, so second half of the 6-1 homework, we're going to get into our word problem. Start with 46. Alright, so we need to, for part A, draw a triangle to represent the situation described above. A flagpole at a right angle to the horizontal is located on a slope that makes an angle of 12 degrees with the horizontal. Alright, let's start with the slope. So we've got this slope going up a hill. Here's our horizontal. Tells us that's 12 degrees down here. Then we have our flagpole. Okay. And our flagpole makes a right angle to the horizontal. So the flagpole is standing at a 90-degree angle. Alright, the flagpole's shadow is 16 meters long and points directly up the slope. That means we've got a shadow coming in here. From here to here is 16. And lastly, the angle of elevation from the tip of the shadow to the sun, which we'll have our sun up here, the angle of elevation would be this angle in here is 20 degrees. So let's use what we know from algebra. If that angle in here is 20 degrees, then we also know we can do this. We can make an angle in here of 20 degrees. And then if this is 12, then this is 12, and then this is 12. So we'll have 20 plus 12. So I'm going to redraw our triangle. If we have it in red, we want... Can we draw in different colors? Come back. How about green? There we go. This triangle here is the triangle we really want. And so let's draw it. We've got 20 plus 12, or 32 degrees. We've got a side of 16. We want to know how tall that flag is, the height here. And so do we have enough information to figure this out? We're going to need one more angle. And so we can figure out this top angle up here. We know, because the angle of elevation here was 20, then this angle in here is 20, which makes our angle on the inside 70. And so we're all set up to solve for h. We can do that with the sine of 70. I'm going to put it on the bottom of 16 because I want to know height, and I like to keep the variables we don't know in the numerator. Just makes it easier for calculation. Sine of 32. Move that around, and you're going to get a height of 9.02 meters. Alright, our plane flies 500 kilometers from Naples to Elgin, turns around and flies 720 kilometers from Elgin to Canton. We're using bearing here. So bearing, if we haven't learned it or if we've forgotten, means start from north and then spin counterclockwise to find here. So they say we have a bearing of 316. Which is how we end up with the 44 here. That's 360 minus the 316. You get 44 degrees. So remember, bearing always starts at north and then spins towards the east to come all the way around. So we want to find the bearing from Elgin to Canton. So from this dot, pointing north, what is it to spin all the way around to that line? Well, let's figure out a few things. First of all, we know that this angle in here is going to be 46 because it makes a right angle. 90 minus 44 is 46. And then we can go in here and we can also figure out this angle in here. How would we figure out that angle? Well, we know a couple things. We know two sides. And we know an angle. So we can use our law of sines. Sine of 46 over 720 equals sine of, I'm going to call it C down here for Canton, over 500. Plug that in, we're going to get sine of C equals 30 degrees. Approximately, you're going to have to round it off. I did that by using the inverse sign there, and usually we have to check for two different angles, but in this case we know it's the acute angle because of the way it's drawn. It's drawn for us, so we know that that's 30. Alright, so we have 30, we have 46. We want to find out our bearing. So on this one, we need to think back to geometry. If this angle is 30, then so is this one. If I want to spin around starting from north, I'm going to go, let me draw in a coordinate plane, 90 degrees, 180 degrees, and then 30 short of 270. What's 270? Take away the 30 that we've got, you'll end up with 240 degrees is your bearing. Let's take a look at 50, railroad track. All right, our railroad has a chord of length 3,000 feet. Let's remember what a chord is with a central angle. So we have a bend in our track. The chord is the straight line across it. So they say that is 3,000. Our angle's 40 degrees. For part A, let's draw a diagram. We have that. Labeling S and R. And R is both sides there. So with that, we actually know the other angles because, remember there's 180 degrees in a triangle. Take away your 40, you're left with 140. If our side lengths are the same, then these two angles are going to be the same, and they're both going to be 70 degrees. So knowing that, we can figure out our R using our law of sines. We're going to say 3,000 divided by the sine of 40 is equal to R over the sine of 70. Punch that in, and you're going to end up with an R, a radius, of 4385, approximately 0.7. And that's in feet. Is that true? Yes, feet. So that was part B. All right, part C says find the length of S. We got to go dig back into our chapter 3, I believe, maybe chapter 4, 4.1. For part C, we need to know S. If you remember, equals R theta. You have a good memory. S equals R times our angle. But if you also have a good memory, you'll remember that it has to be in radians. So we're going to convert by going pi over 180. Our angle was 40, but we can't leave it as 40. We have to convert it. So plug that into your calculator, and you'll get a final answer for S of 3,061.80 feet. That was for part C. All right. 2 to go here, 52. Let's locate this fire. All right, so they give us some information, 80 degrees from here to here, 65 from here to here. I'm just going to right away figure out that this angle here is 15. Do the subtraction. And we've got 70 degrees. If I were to make a right angle, that makes this 20. If I were to make a right angle, I know that that angle in there, if I bring it all the way across, there's 90. The other part of my triangle here is 65, which makes this angle in here 25, which makes the rest of this in here, 90 minus 25, 65. All right, so we're figuring out all of our angles. We want to find two lengths. We want to find this side, call it X, and we want to know from here all the way to here, call it Y. And so let's use our law of sines. We know that 30 is across from this angle. Sorry, don't have that angle yet, but we can use 180 minus 15 minus 65 minus 70, all the angles that are inside that triangle. And if we do that, we end up with 30 degrees over here. So sine of 30 matches up with 30 kilometers. And x over the sine of x is opposite 15 degrees. Plug that in, you're going to get x is equal to 15.53. we can also get rid of x, get rid of the 15, and say y over the sine of we're across from 135. You plug that in, you're going to end up with 42.43. All right, last one, 54. Family is traveling due west on a road. Start drawing. Here we go, we're going west. All right, at a given time, the bearing to a landmark is north 62. So I'm going to, from north, I'm going to rotate 62 degrees. Here's my landmark. That was 62 degrees in here. All right, I keep traveling along. Travel, travel, travel. I go 5 miles to here. And then my bearing from north to here ends up being 38 degrees. All right, and so we want to know what's the closest we'll ever come. Well, the closest we'll ever come is the 90-degree angle. So we ultimately want to find our distance d there. But let's figure out if we can solve the original triangle here first. So we know that we've got, let me redraw it over here to make it a little more clear. 62 taken away from 90 ends up being 28, so we've got 28 degrees in there. All right, 38 plus another 90 is 128, so that would be 128 for our obtuse angle. Didn't come out very well, 128 down in there. And we know that this bottom side is 5 miles. All right, so the 5 is going to match up with the sine of our third angle up here. We can find that by subtracting from 180. We end up with 24 degrees. And let's go ahead and find this side over here, x over the sine of 28. Plug that in and we end up with x equals 5.77. So that's this length here. I'm going to redraw there. Right triangle now. We've got a length of 5.77. That's our hypotenuse. We want to know d. And we know that we have an angle in here of 38 taken away from 90. And so if we do that, we end up with 52 degrees. All right, so if we go from our angle and we want our opposite and hypotenuse, that's going to be sine. Sine of 52 is equal to the opposite over the hypotenuse. Plug it in, and our distance is 4.55. All right. Any questions? Let me know in class, and we will go over them.